Welcome to Forbes Podcasts.
Hi, everyone. Welcome to Unchained, a Forbes podcast produced by Fractal Recording. I'm your host, Laura Shin, a Forbes contributor covering blockchain, digital currencies, and fintech. Thanks for tuning in. Today, I have a special guest, Bill Tai, one of the organizers of the Blockchain Summit recently held on Sir Richard Branson's Necker Island, and a well-known venture capitalist and kiteboarder who runs MaiTai Global, a nonprofit that runs tech and kiteboarding events around the world. Bill's had a long career in tech and is the kind of person who can see the next waves in technology happening from miles away. Hi, Bill. Thanks for coming.
Hey, Laura. Thanks for having me.
So you've had a legendary career in Silicon Valley. Tell me how you got started.
You know, I think it's all about being in the right place at the right time. I was trained as a computer chip designer at the University of Illinois. Illinois happened to have a faculty member that was one of the co-inventors, three inventors of the transistor. So they got sort of an early start in the technology area. Later, companies like Netscape came out of Illinois. So it's always had a long history of technology. Having been trained as a semiconductor device person, when Silicon Valley was kind of ramping up commercially in that wave in the 80s, I came out here to join a very young company, a company called LSI Logic, that was founded by the CEO of Fairchild Semiconductor, which was really kind of the progenitor to the entire tech ecosystem that we now know as Silicon Valley.
And what do you, when you say it was the progenitor of that ecosystem, tell me more about.
Yeah, so Silicon Valley has the name Silicon in it because, one, it's a valley that used to be a bunch of orchards. When I moved to California, the back of my apartment lot was a cherry orchard, C.J. Olson cherry orchard in Sunnyvale. It's now car dealerships. But at that time, a company called Fairchild Semiconductor had exploded onto the scene. And there were a number of companies that formed by executives or engineers leaving Fairchild to start companies like Intel and Advanced Micro Devices and National Semiconductor. And there are a bunch of books written on it, but I think there's 100 companies that came out of Fairchild that became the roots of basically everything we see in Silicon Valley today.
And what are some examples of those things?
Oh, as I mentioned, companies like Intel and, the very formative layer of technology that has become the basis for everything we use today that has any electrons running around in it, really kind of came out of that rootstock. And there's a book on the kind of the history of Silicon Valley that sort of highlighted 5 of those companies that came out. And I mentioned Intel, National, AMD, Zilog is another one. The Z80 microprocessor is pervasive. You probably have it in your TV, your remote control, or your microwave oven. The CEO of Fairchild, or one of the CEOs of Fairchild, left to start a company in 1981 called LSI Logic. And his name was Wolf Corrigan. I ended up joining that startup in 1984. And it was a rocket ride. I left to go to Harvard Business School to get my MBA, and then upon completing that, ended up doing a very short stint in Taiwan to help the government of Taiwan set up their own semiconductor industry. And it was a government-backed project where they put up, I think it was $400 million, borrowed process technologies from Hitachi and VLSI Technology and companies like that, set up manufacturing, and I helped do a spreadsheet that described what that first manufacturing facility would be like and was issued a consulting badge, A001. That little project has resulted in a company that today has a market value of around $130 billion. It's roughly the same value as IBM, or maybe 6 times the value of Hewlett-Packard, maybe 1.5 times Nike or 2 Ford Motors. So it's quite a large company, but that was my introduction to technology. I then went into the finance side and became the semiconductor analyst at Alex Brown. And for 4 years or so, I ran around the valley looking for little companies that might get big someday, and I would list them on the stock market in terms of being the positioning of what the companies did to investors so that they would buy shares. And I took public companies like Atmel and Zilog and Cirrus Logic, 13 or 14 companies. And then I turned 29 and went into venture capital. and started funding similar kinds of companies, semiconductor-based companies, and then started to migrate up the stack. So then went on to do sort of routers and hubs and switches. I started an internet service provider in 1994 that ended up going public. We grew into the position of being a data center operator in 12 countries in Asia. Goldman Sachs, Morgan Stanley, and Solomon Brothers shared the IPO of that company called iAsiaWorks after I brought on the then CEO of AT&T Asia Pacific to be CEO of the company. But since then, I've been kind of riding technology waves ever since.
And why did you make that switch to venture capital?
I really loved the startup environment when I joined LSI Logic because I'm basically a builder. While I act as a financier, I'm not somebody that just writes checks. I tend to have ideas in my head about what should exist, and if it doesn't exist, then I go and recruit teams to go make it. In fact, we're sitting here in the offices of a company called Treasure Data, which I had an instinct that we needed to have a very easy-to-use, scalable data infrastructure for big data in this modern world. And so I ended up putting together a team of engineers to create this company, which now has like 200 enterprise customers that have thrown into our system 40 trillion rows of data in 3 or 4 years. And they are still throwing in the time it takes me to finish this sentence, there will be 8 billion more rows of data because they're throwing about 1 billion rows of data into our system per second, 24/7. So so I enjoy building, and I wanted to be more at the roots of the creation of companies rather than just sort of observing from the outside and listing them on stock exchanges.
Okay. So I'm sure as our listeners can tell, one thing that I gathered from you when we were on Necker is that you kind of have this very long view of the evolution of tech. And on the island, you gave a presentation about these 6 waves of technology. Can you describe that for our listeners and explain where you think blockchain fits in?
Sure. And this one I can do very succinctly. So wave 1, in my opinion, was basically a bunch of scientists turning physics into usable products. So the semiconductor wave, taking atoms moving around, but putting them in little black plastic packages with spider silver legs that you could use as Lego blocks to build stuff. So there was a lot of commercial activity building companies in wave 1 that were semiconductor companies. Wave 2 was about taking all those little building blocks and building stuff out of them. So companies that made either computers or hardware devices, communications gear, switches, routers, hubs, etc. There was a gigantic wave of value creation around companies that were built like Cisco or Apple or Dell or any company really taking the little packages of physics and turning them into boxes that could move atoms around. Wave 3 was the assembly of those boxes and stitching them together into local area networks, the LAN, wide area networks, the WAN, and the culmination of all that was basically a worldwide network that we now call the Internet, LANs and WANs all working together in an internetworked operation where you could basically transfer bits of ones and zeros running on all those atoms from wave 1 and 2 anywhere you wanted to go and shape them in any way. And that was also a giant value creation wave of ISPs and data center infrastructure. The next wave after that, wave 4, was basically attaching a user interface onto that giant network. And that's the wave that I think everybody knows because it became very consumer friendly. Rather than sort of hardware protocol engineers in back rooms making things and making networks that ran information, the world moved to basically kids like Mark Zuckerberg starting things like Facebook in a dorm room, or Jack Dorsey writing Twitter in 7 days, which the fund I put together seeded. And it became basically a value creation wave based around the appearance and the usage of the bits coming in and out of the network. So if you think about it, Twitter, LinkedIn, Zynga, all those companies, Facebook, they're really just user interfaces to ones and zeros coming off your screen. And it's what those ones and zeros look like in aggregate that stimulates usage and behavior and creates value. The wave after that was a data science wave, which we're still in, and which is why Treasure Data exists. The companies that really won, because in any space where people were trying to capture user behavior, there were many, many companies in that wave. And the ones that won were the ones that got a handle on measuring, monitoring, improving what users did on their screens because they knew what was happening and they measured it. Mm-hmm. And that's what data science is. So knowing what the science of knowing what your data is doing. So that one appears to be a gigantic wave because you have companies that have clearly moved data science out of just web companies into the physical world. If you think about the success of a company like Walmart, Walmart is effectively a data science company with a physical front end that's a store because they're watching all the stuff moving around inside. They're very efficient at knowing where it is. Companies like JCPenney and Sears never got it. So they're basically piles of transient inventory that create write-offs every once in a while. Mm-hmm. And so data science, I think, is important to everybody and a very foundational wave in Wave 5. So as we move forward, now we're starting to attach physical things to the data science. You can see that in companies like Uber or Airbnb. Airbnb or Uber are really a room or a car attached to a data science infrastructure where you can transfer the ownership of a car for 5 minutes with an iPhone app. And that brings us to blockchain. So where we are today is we're in a world where people are now used to a term that I call virtualization, where a physical thing or a piece of value is virtualized into a bunch of bits, and you can move them around the transport stream. One way to look at it is, when the internet hit, people were using faxes before the internet, where you would basically write a note, handwritten or typed, and then you would basically surround that note with a bunch of ones and zeros and then drop it into the TCP/IP transport stream. TCP/IP meaning Transport Control Protocol / Internet Protocol. And that little set of words would know where to drop into the system and where to come out of the system in the form of your email. And now we're basically doing the same thing to physical stuff, whether it's a unit of value that can be expressed in a Bitcoin, or soon the title of a car or a house or a piece of land or really anything. So I think I wrote a Medium post recently called Blockchain is to Banks what TCP/IP is to telcos, because it's basically a way to take all the stuff flowing through a system, whether it's a communication systems like telcos, you chop it up into little bits, and it allows the pieces to flow through that cloud and come in, disaggregate, reassemble super efficiently. We're now doing that with physical things, with the blockchain. So that's, I think, where we are today.
Wow. It's so fascinating to hear you describe all these waves. I mean, this is like, I can sort of just go back and remember, different levels of technology in my life. Like when I went to college and used Pine and Elm to check my email and stuff like that. And then obviously now, I can check on my phone. And I just love hearing this evolution. So one thing that interested me in your description is when you talked about like the LANs and the WANs kind of coming together to form the internet. There are so many comparisons that are made in like, the way like Bitcoin and blockchain are developing now and comparing them to the internet. How would you make that comparison? Oh,
I think it's, in my individual opinion, I see it also. I think what you're seeing now are little islands of activity that are springing up everywhere that will eventually kind of internetwork and merge. And in the days where the internet was forming, the term internetworking, it really refers to the meshing of different kinds of networks. So if you clock back to the sort of the early 90s or mid 90s, there were a plethora of different kinds of networks, and people may not even remember these, but there were Novell networks. There were TCP/IP networks. There was the Unix network, Sun Microsystems that came out of Stanford Unix network, or Stanford University Unix network, whatever it was. I don't remember the exact terminology, but there were many, many different kinds of networks. And then companies like Cisco came along with a multi-protocol router, meaning it would sit in between these various kinds of networks and translate the format from one to another so that Len and Sandy Bozak, who founded Cisco, could send emails to each other, even though one was on the Stanford network and one was on the Novell network. It just sort of instantly translated. So now I think what we're seeing is the formation of little private networks in banks and other institutions where people are basically transacting and trading in a certain way, and they're forming little communities that I think will be the foundational blocks to broader communities when they're all basically internetworked. In this particular case, the protocol kind of already exists because the blockchain's already there. And I think the world has gotten used to the social virality of communities jumping onto certain technologies. You know, for example, messaging technologies. Yeah, there's a lot of messenger things around, but people know that the value of a network grows exponentially the more people are on it. And people recognize that, you know what, they've seen it before, they're going to see it again, and people hop onto the platform that has momentum. So you see that today in blockchain. There are other great technologies out there like Ethereum or some other kind of chain X, blank X meaning, it could be anything, X blank chain, this and that. But I think what's happened is the developer community has largely centered on Bitcoin blockchain. So the momentum of human energy to fix anything that's not working is there. Kind of like, any open source movement, you end up getting the best results where most of the brain power exists. And in the case of, whether it's Linux or internet related things, I think you go to where the action is, and all the action today appears to be in Bitcoin blockchain.
Okay, and earlier when you were talking about the communities that the banks are developing, are you talking about private blockchains, like maybe things like the R3 consortium that they're doing with Corda and stuff like that, or did you mean just like legacy systems?
I'd say more the former, meaning that there's a lot of development activity with people trying to figure it all out. And, before the internet was pervasive, financial institutions and others that had the resources to build their own private messaging networks had them. They had private networks that later were then added on to the information superhighway where all of it kind of was able to go from one place to the other. And I think, people already have private transaction systems that work. They may be a little bit high overhead. And I think what will happen is just as TCP/IP sort of in a positive way infected all those networks as a virus and sort of carved them out from the inside, and things got more efficient, more liquid. I think that's what you're going to see. Anyone that's already in the transaction business is going to look at the new development and say, wow, I could do exactly what I did before, and it's going to be 1/10 to 100th the cost per transaction. Why wouldn't you do that? And I think what happened in the world of telcos is as telcos started to see that all of their fixed lines hanging there empty most of the time, if you basically chopped up the conversations into little pieces as they float onto the network, you could kind of mix them all up and use more infrastructure more efficiently by multiplexing all that stuff onto those little lines that existed.
And are you referring to voice over IP in that?
Yes, data, whether it's voice over IP or voice over IP is effectively voice put into data packets. So it's data of any form, including voice, being chopped up into pieces and able to be kind of time shared onto lines. That's kind of what the internet did to the phone system. It just made it far more efficient and far more flexible. And I think blockchain is a similar thing where it's going to introduce the ability to move assets around a lot easier, and also create a way to build applications on top of that platform to do higher value added levels of service, which is exactly what happened with the phone companies. There were a bunch of early voice over IP companies. I've forgotten all their names, but a lot of companies would ride on top of ISPs and try to charge less for phone calls on the very expensive structure of the phone company. So the phone companies were losing money on it, but the VoIP companies were making money. And then the phone companies started to say, well, heck, we could do that too. And not only could we do that, we could also build on top of it all kinds of, kind of voice forwarding or whatever, all kinds of other messaging things. They could provide data services, news and information services, anything that could be packaged up in a bunch of bits. And I think we're going to see that as well in the ability to deconstruct and reassemble and then aggregate more things to higher chunks of value as assets, physical assets, instead of conversations, get chunked up into little bits and thrown onto the blockchain. It's all very exciting.
There's two different strands of points that you made that I kind of want to pull together and put them head to head. At one point, you talked about how you thought, there was a network effect around Bitcoin and how that was going to do really well for that reason because there's like developer activity there. And then later on, when you talked about voice over IP, you said that the telcos kind of caught on and they started adding these services. And so in that scenario, it's more like the incumbents were ended up being victorious, and it wasn't necessarily the open protocol that kind of won. I mean, maybe even one isn't the right word, but in general, I feel like a lot of people talk about this in us versus them kind of way, like the startups against the incumbents.
Yeah.
So, where do you see blockchain going? Like, do you feel like it's going to be, the startups are eventually going to be kind of more dominant,
it's interesting to draw an analogy. I think in the beginning of the commercialization of the internet, it did feel like there was a little bit of a we versus they mentality with the startups trying to ride on top of telco infrastructure. And you have the same sort of thing with the banks today and startups trying to do fintech based on blockchain or anything else. That said, what ended up happening in the internet was everybody won. Life is better because it all merged together because it had to. And if you think about the virality and network effects of a communication system, period, if you're on a system and no one else is there, there's no one to call. And so if there's two people there, you can call one person. If there's a third person, you can call two. If there's four people, the number of conversations goes up in an exponential way. 4 points means 6 connections. 5 points means, is it 25? Somebody can do the math, but, the number of lines between the dots goes up exponentially. So the value of the network goes up a lot faster than the number of people. It's if 2 goes to 3, the value just didn't grow by a third. It grows more. And so I think financial transactions are the same. If you have a shell from the ocean that is a piece of currency and there's nowhere to spend it, it's not worth anything. But if you're plugged into a community of 50,000 Polynesians that trade shells, then you're part of an economy. And so I think what's happening now is that we have these little elements that are touching the economy in their own little communities, and it's all going to become sort of standardized onto a common platform. And then the friction goes way down, the number of transactions goes way up, the cost of doing transactions goes way down, and it just becomes a lot easier. Communications is so much easier today than trying to send faxes. And I think commerce is going to be the same thing. Okay.
So I know, you decided to create the Blockchain Summit. I also know you're an investor in some of the blockchain companies like Bitfury. In general, when you are looking at the space, what do you feel like it needs right now?
I think we're, it's not unlike the internet in 92, 93, 94. In that period, I was running around at O'Reilly tech conferences, picking up floppy disks to stick in computers to see what a Gopher was, or an FTP, like, how do you use an FTP client? And why would I use an FTP client to send a file? Like it made things easier in the long run, but in the short term, it was a little harder and a little complicated and a little bit difficult to understand. And I think we're kind of at that phase with blockchain and Bitcoin and related technologies now where it's clear what the promise is. Low friction, very fast, low cost commerce. That's clear. But learning how to use it is a little bit of an impediment. Because I think people are used to things, they got to kind of get over their past learnings of how to do certain things. Heck, I even still write checks sometimes.
I did do that yesterday.
Yeah. So, for there's certain things that won't go away. Like when I invest in a company, I actually like to have a physical record of a check that I write, and then I PDF that, and then I scan it, and I send it to myself, so I have multiple copies of different types. So I think there's some things that people will still behaviorally never get over.
As I mentioned, you have invested in Bitfury, and they started as a mining and chip manufacturing company, and now they're expanding to blockchain services. Using the lens of how you decided to invest in them, can you explain, when you look at the state of the blockchain industry right now, how would you analyze it as a VC?
Okay, well, so I'll start with, how did I come across Bitfury? Why did I invest? Funny enough, one of the early members of the community that produced Bitfury. So Bitfury really started kind of as an open source community. Bitfury really started within the open source community. There were a couple of people that met online in forums while they were teaching each other how to mine Bitcoin. And they started in the days when you could basically download a program to your laptop and run it and get rewarded every once in a while by winning a little bit of coin. And as the world got more competitive, they would fall behind periodically and need to improve their performance. So they went from software running on laptops to teaching themselves how to use graphics cards that process pictures a little bit better, speed things up. And then they moved on to programming field programmable FPGAs, field programmable gate arrays, which you could implement certain algorithms in and make them run pretty fast. And ultimately, they were winning in that space and then got a little less competitive. And one of them said, we need to make our own chip. And they all kind of looked at each other online because they were in physically different places and said, does anyone know how to design a chip? And none of them did. So they taught themselves how to design a chip. And it was a little rad because what they ended up doing, because they didn't have prior institutional knowledge, is they went completely outside the rule set of how you would ever do anything. And they handcrafted the transistors in a world where silicon design has migrated to a very high-level experience where everything's automated. And today, if you're in school learning how to design computer chips, you basically come up with tables of ones and zeros. There are ones, inputs and outputs, and then you do Boolean algebra on the middle to try to make the input match the output. And then you load that up into a system, you hit a button, and a computer synthesizes the architecture and prints the transistors for you. So they didn't know how to do that, and they couldn't afford the tools. And so they basically, step by step, designed their own transistors and their own architecture, and it worked. And they went so far around conventional wisdom that their silicon and their approach was just far more efficient than anything else out there. So in a game where most efficient use of power and high throughput of calculations matters a lot, they just started winning big time. So the company ramped up very fast and soon found itself to be kind of the technology leader in the space. And along the way, I guess I had been on the board of directors of public companies that had made math coprocessors, designed lots of transistors. And when I saw what they were doing, I said, wow, that actually, it works. And it's totally revolutionary and defensible. So I led an angel round and wrote a check, and here we are. So soon.
And that's the development story of the ASIC?
Yes, that's how that first ASIC happened. Yes.
And was it who was on that message board?
Oh, that was Valerie Vavilov, the CEO. Valerie Nesby, who's their chief technologist in the Ukraine, and Nico Punin, who is I think he's now heading marketing, but he's kind of the universal do everything guy in the company, and they're just a fun, crazy crew to work with. But so soon they ended up with data centers in Iceland, Finland, and the Republic of Georgia, converting anywhere from 40 to 100, a million watts of electricity into Bitcoin in real time. They were massive, and they stumbled their way into running basically the world's largest consolidated blockchain processing infrastructure. And as I joined the board and started to think about what they could become, I talked to George Kikvadze, the vice chairman, and Valeri, and I said, the thing that you guys should think about is this is a bigger play than just piling up a bunch of Bitcoin. What we need to do is turn this into the foremost blockchain processing infrastructure in the world, and come up with a way to basically move it forward to a point where developers can build stuff on the system, and you can run anything on it, not just like run stuff to make a lot of coin, a lot of Bitcoin here and there, and turn electricity into money. So we embarked on that strategy, and I said, what we need to do? The thing that we're missing is we are missing a community of thought leaders in one place. And if you hearken back to the formation of Silicon Valley from 1975 to 1986, there were a bunch of kids that loved technology, whatever it was at that time, and they would meet at rooms at Stanford University, ultimately renting rooms from the Stanford Linear Accelerator. And those kids would basically show up with their little pieces of wood with semiconductor chips sitting on them that were wired together doing things. And those kids were kids like Steve Jobs and Steve Wozniak and Bill Gates and Paul Allen and Andy Bechtolsheim and the guys that started Sun Microsystems, or Alan Shugart who started Seagate. And it was the interaction and communication real time on projects that led to the creation of enough sort of standardization and enough critical mass around movements that massive commercial waves were formed. And we just didn't have that in the Bitcoin blockchain environment, because the world had gotten so distributed due to the internet that people were off working on their own little projects, and communication would happen online, but the human-to-human interaction wasn't there. So I said to those guys, let's get a bunch of great people and stick them on an island for a couple of days, and let's invent stuff that we can put on the blockchain. So, and I said the other thing that was missing was Bitcoin had this sort of nefarious reputation as a place where drug dealers and people buying and selling illicit goods would hang out. And, I don't even drink, So I said, what we need to do is let's let people understand what the potential is, and let's make people create things for social good. So we took the group of people we invited. They were kind of, of a certain type of person, creative people that knew the technology, that could invent things. And we divided everybody up into groups of 6 to 8 people, and we gave them 24 hours to invent something that could do social good, but run on the blockchain. And we had like 8 or 9 projects come out of there that got a ton of traction. So John Edge's and Lucy Liu's project, which had been kind of born before but took shape on at Necker Island, they presented in front of the United Nations about 6 weeks ago with the ID 2020 project.
Yeah, I was there.
Yeah, so amazing that really got traction at Necker Island. And the Virgin Galactic astronaut trainer, Beth Moses, she had a fabulous idea to create a liquid carbon credits marketplace based on the blockchain. And that's still a great idea. I hope she runs forward with it. Nico and I spent a little time thinking about, well, how do you get the next generation of kids to understand this in a way where they don't really have to learn anything? Because one of the things to make this world really absorb it, you need to have the next generation that doesn't have credit cards. You want their first touch to be something that's easy to use. So we came up with a Bitcoin light bulb. And what is a Bitcoin light bulb? We basically took a power supply that takes your wall current AC to DC, stuck a chip in there, so a microprocessor from Qualcomm, a Bitfury mining chip, and a Wi-Fi chip, and we stuck it in a light bulb. And the idea there is to anybody could take a light bulb, screw it into a socket, it sees Wi-Fi, you turn on your iPhone, you connect to it, and it's mining Bitcoin for you right away. And when you sign into it, We want to do this on Facebook. So Sean Ryan of Facebook, if you're listening, this is where I need your help. We want people to just basically sign in, and it posts on your feed. I'm Laura Shin, and I'm mining Bitcoin. Come join me. And all your friends can click on that link, get a light bulb, join your pool. And then suddenly you have dozens of friends in one collective entity mining away. And Sean, this is where I really need your help. I want people to be able to basically just send Bitcoin to each other in Facebook Messenger, independent of how old they are. You know, my son, he
can't. Why
can't.
wouldn't we just use the Bitcoin blockchain to do it? Why wouldn't we use Facebook Messenger?
Well, you have. What does the light bulb do for you? It sets up an account for you. It's already mining. It puts money in your account. It's connected to other people already there, so it lowers the friction so kids can use it. You know, so just sort of like,
but are kids using Facebook? That's a question.
You know, that's a good point. So Sean, you got to work on that too. But I think there are ways to basically use existing social networks to plug the transaction. You know, it would still run on blockchain, of course, but I think the interface could be things that are already familiar to, in that case, 600 million people. And a lot of them are probably not old enough to get a credit card, so it's their first experience. But I think there were so many projects. The Blockchain Alliance was formed in Richard Branson's hot tub on a conversation, and I think it's now basically the largest group of important blockchain companies working on law enforcement. So there's all kinds of things that came out of that are just fantastic. So it was fun to see over the course of a year what could happen, and I'm really excited to see what happens going forward.
Okay, so as a VC, when you look at blockchain, what do you think are some good opportunities in the space, and what bets do you think are less likely to pay off?
Oh boy, I think it's so open-ended right now. You know, if you think about what happened in the 90s, a lot of things worked. And I think there was so much momentum behind the internet segment that there were probably a lot of things that kind of worked financially that didn't really work as businesses. But, you know, the tide was rising so fast. We're not quite there yet, but we're in the phase where things are kind of bubbling up a little bit. And I don't think people are euphoric yet about the segment. So I think we're at a phase where we're still kind of picking shots. And I think the things that I think I'm interested in are really probably two main areas right now. One is the application of blockchain to land titling. I've embarked on a project with Hernando de Soto, who's the president of the Institute of Liberty and Democracy, and we basically architected a system that uses blockchain at its core, that takes the work that he's done over 20 or 30 years to basically aggregate and define titling of land, and to put it into, in his prior case, paper-based systems that now can be fully automated, done with iPads and iPhones, and sucked into a set of databases that runs on top of blockchain, and lowers the friction completely to giving people assets that they can then have title, take to the bank, get a mortgage, and have kind of the very basic capital, the foundational brick that forms capitalism.
And can you describe the problem because I mean, in a place like the U.S., you know, this is something that a lot of people already have. So can you describe what it's like in other countries?
Sure. Yeah. So I think Hernando de Soto and the ILD, they're really famous for one thing they did that was remarkable, which was stopping the civil war in Peru, and without firing a shot. And it's kind of a weird thing, but how did that all work? Well, back in the 70s and 80s and 90s, the Colombian drug cartels were very prominent. Colombia sits next to Peru, and they had a lot of influence on squatter farmers all over Peru, growing cocoa leaves to then be shipped to Colombia to be turned into drugs and then reshipped to America for billions of dollars, which then was fed back to help fuel an army, a terrorist army called the Shining Path. And the Shining Path controlled 70% of the landmass of Peru. And they did that for decades. And the government itself didn't really have a lot of resources, so they couldn't fight the war properly. 3 presidential administrations in the USA spent billions and billions of dollars trying to stop the drug flow in the so-called war on drugs. Totally ineffective. But Hernando, the economist, convinced the president at the time, Alberto Fujimori, that what he needed to do was use behavioral economics to align people's interests with what the government wanted. And he basically orchestrated a land reform program where he walked into the jungles, would approach a squatter farmer and say, "Are you tired of the Peruvian army burning down your house every 2 years and shooting at your family? Do you want your kids to go to school someday? If the answer is yes, then just sign here." And what you're signing basically says that that little green plot of land that you will deny that you're working on today now is your property forever, as long as you don't grow illegal crops. So as long as you grow legitimate, acceptable crops, you keep that land in your family forever if you want, or you can sell it. And so over a period of 5 to 7 years, Hernando cut the supply chain off of all the drug dealers, and the war ended. And so he then took that basic principle, formed the Institute of Liberty and Democracy, and has applied that in another 15 or so countries over 2 decades. And what I'm working on with him is automating that process, because he basically did it with a lot of paper forms and armies of people running around surveying squatter farmers. And there's a way to basically do that very quickly and very clearly and put it on the blockchain. So that's one project I'm excited about. The other is just the general level of transparency of, what can you, everyone hears that the blockchain is transparent and that you can see all these transactions, but then there's this kind of, whoa, but then why did Silk Road happen? And why are all these criminals around? They're like, what? I don't get it. Like, if I can see everything that's happening, how come I don't know who the criminals are? Well, in my opinion, it's really just user interface. So there was a company that I am part of the seed backing of called Blockseer. And I met a young man named Danny Yang, who is a Stanford PhD in data science, who had run the Bitcoin meetup group at Stanford University. And he gathered a little bit of capital initially to create a company that is running pretty well now called MaiCoin, M-A-I Coin, which is a Chinese language Bitcoin wallet company. Think of it as sort of a Chinese language Coinbase for Taiwan and some other countries. And I said to Danny, Danny, your background is so unique in data science. The wallet business, it's going to exist, but there's like lots of wallet companies, and I think MaiCoin's going to be a great success in those geographies. But let's do something cool. Can you create something that looks a little bit like a Google search page, where all I have to do, if I'm going to do a deal with Laura Shin, she sends me her wallet address, I copy, paste, click it in there, and then I can see every coin that Laura Shin owns in her wallet, know where it came from, know every transaction she's ever done with that wallet in her history, and I can get kind of a feel for, is she legit? Is she not legit? Is she like spinning money around in and out of Mt. Gox? It's a way to provide a level of transparency and just put it in front of the public eye in a very easy way. So he wrote it. And so Blockseer today is still a seed-funded company whose product is being used, and I guess I can't say who they're being used by, but they are being used by 3 or 4 government agencies that have 3-letter initials. So everybody's using it, and it's a great product. But check it out, blockseer.com.
Okay. What have I not asked you that you'd like to discuss?
I don't know if you're interested in kiteboarding. I can always talk about that, but that may not fit into this podcast. But I think
but I am curious, how you got into that and then how you ended up blending it in with your tech background.
So I started as many years ago. I learned how to sail a little like an interclub sailboat, and it was fun, but it wasn't fast. So I moved to smaller craft and eventually started windsurfing. And windsurfing, it's a very visceral experience because you're skipping across the water and you're flying and you feel the air, a little bit different than being on a boat. And there was a natural progression of people that were windsurfing into the sport of kiteboarding because they were all sort of water athletes. And I just happened to be kind of in the right place at the right time. with a bunch of the kind of professional athletes that were windsurfers. I used to ride with them to train and things like that. And they started to pick up kiteboarding around 2000 when the first controllable kites were made by companies mostly in Hawaii. And so I inherited a kite that had once belonged to Laird Hamilton, the surfer, and taught myself how to kite in 2001. And I've never looked back. And then somewhere along, kind of around 2003 or 4, somebody took some pictures of Sergey Brin and Larry Page kiteboarding in the bay. And that coincided with this giant wave of sort of, young people starting tech companies all over the valley. And everybody wanted to emulate what, successful founders were doing. So the sport suddenly became really popular in that community in 2004, 5, 6. And here I was as sort of the old hand and experienced guy, and an annual trip that I would throw on Maui with the now CFO of Yahoo, but this was like 15 years ago, became the place to go and the network to be part of if you were a hot young entrepreneur that wanted to learn to kite surf. And so I started to have these gatherings that grew and grew and grew in size. And now I have this worldwide community that's known as MaiTai Global. The Mai in the MaiTai. Tai is obvious because of Bill Tai, but there is a Susie Mai who is a professional kiteboarder. She was a Red Bull athlete that was a Red Bull King of the Air winner 3 years in a row. No other athlete's ever done that. And she came out to help me with one of my gatherings once, and it got lovingly nicknamed MaiTai by James Hong, I think the founder of Hot or Not, and Salar Kamangar, who went on to create AdSense and run YouTube. But the tech community sort of branded it as the place where tech meets kiting, meets deal generation, meets investing, and so I spend my time now kind of going from place to place, creating these little salon discussions, whether they're blockchain summit or my extreme tech challenge or other things around the world, traveling around and having fun with entrepreneurs creating companies.
It's a life to be envied, I would say.
I have to say it's pretty fun. I do not regret how my life has played out.
Okay, great. Well, thank you so much for taking the time to talk with me. It's been a pleasure having you on the show.
Thank you, Laura.
Thanks for joining us today. If you're interested in learning more about Bill and his work, check out the show notes, which are available on my Forbes page, forbes.com/sites/Laura Shin. And please review, rate, and subscribe to the show in iTunes if you like what you're hearing. Thanks again.
You just enjoyed a Forbes podcast. To learn more about our other shows, visit Forbes.com/podcasts. Thank you.